Hello everyone, in this video we will discuss three-dimensional geometry from class 12 mathematics. We are going to cover the topic in this video. First of all, direction cosines and direction ratios of a line. Then, relation between the direction cosines of a line, directions cosine of a line passing through 2 points. For this, we have to imagine a three-dimensional coordinate system containing x-axis, y-axis and z-axis. For this, we have considered a line which passes through origin O. Let the line be OL. Okay, and this line makes angle alpha with x-axis, beta with y-axis, gamma with z-axis. Now we'll discuss direction cosines and direction ratios of a line. As we all of know, then direction cosine and direction ratios, they are proportional to one another. For this, we will consider ABC be the direction ratios of a line and LMN be the direction cosines of a line. Then L by A equals to M by B equals to N by C equals to K, say K being a constant. From this we will get L equals to AK, M equals to BK, N equals to CK. Let me to mark this equation as 1, but we know L square plus M square plus N square equals to 1. If we put the values of L, M, N in this equation, we will get K square into A square plus B square plus C square equals to 1. From this we will get the value of K as plus minus 1 by square root of A square plus B square plus C square. Now, if we put the values of K in equations 1, we will get direction cosines of the line are L equals to plus minus A by square root of A square plus B square plus C square, M equals to plus minus B by square root of A square plus B square plus C square, N equals to plus minus C by root of A square plus B square plus C square. Where depending on the desired sign of K, either a positive or a negative sign is to be taken for L, M, N. For any line, if A, B, C are direction ratios of a line, then KA, KB, KC, as K is non-zero, is also a set of direction ratios. So, any two sets of direction ratios of a line are also proportional. Also, for any line, there are infinitely many set of direction ratios. Now, we'll establish relationship between the direction cosines of a line. For this, we'll consider a line RS with direction cosines L, M, N. Through the origin, draw a line parallel to the given line and take a point P, X, Y, Z on the line. From P, draw a perpendicular PA on the x-axis. Let OP equals to R, then cos alpha, as alpha is the angle which makes the line OP with x-axis, so cos alpha equals to OA by OP is equal to x by r. This gives x equal to LR. Similarly, we can show y equals to MR, z equals to NR. Thus, here you can see x square plus y square plus z square equals to, if you put the values of x, y, z, we'll see r square L square plus r square M square plus r square N square. If you take common r square, you will get r square into L square plus M square plus N square. But we know x square plus y square plus z square is nothing but r square. From this we will get L square plus M square plus N square equals to 1. Now we will discuss direction cosines of a line passing through two given points. For this, we will consider a 3D coordinate system and consider these diagrams A and B. Let LMN be the direction cosines of the line PQ it makes angles alpha, beta and gamma with x, y and z axis respectively. Draw perpendiculars from P and Q to xy plane to meet at R and S. Draw a perpendicular from P to QS to meet at N. Now in right angle triangle P and Q, PQN angle equals to gamma. It is very clear from the diagram B. Therefore, cos gamma equals to NQ by PQ. If you see from the diagram, NQ is nothing but Z2 minus Z1. Similarly, we can show cos alpha equals to x2 minus x1 by PQ, cos beta equals to y2 minus y1 by PQ. Hence, the direction cosines of a line segment joining the points P, x1, y1, z1 and Q, x2, y2, z2 are x2 minus x1 by PQ, y2 minus y1 by PQ, z2 minus z1 by PQ, where PQ equals to, it is nothing but the distance between the points P and Q, is equal to square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Thus we can see direction ratios of a line segment joining point P and Q may be taken as x2 minus x1, y2 minus y1, z2 minus z1, or x1 minus x2, y1 minus y2, z1 minus z2. Thank you.